This question is asked in Gate 23 of Computer Science. This is from digital subjects and related to combination and sequencer circuit mix concept. The question is, the output of a two input multiplexer is connected back to one of its input as shown in the figure. Match the functional equivalence of the circuit to one of the following options like D flip flop, D latch, half adder, demultiplexes. So basically, what we are supposed to do in this case, student, is this circuit is equivalent to which of these circuits? That's what they're asking. Answer cannot be a D flip flop because flip flop means there should be clock. There is no clock. In multiplex, you don't have clock, right? So it cannot be D flip flop. Even answer cannot be half adder also because in half adder there are two inputs, two outputs, right? A, B is the input, some carry as the output. So here it is not possible. You can see clearly. Okay. So half adder is not possible. So answer could be D latch or demultiplexer. Even from the structure also, student, you can see it cannot be a demultiplexer because demultiplexer means one inputs and many outputs, and there is no such feedback and all. So answer has to be D latch basically. Okay, so this is what the answer is by elimination option, elimination of wrong options. But let us understand how this is D latch. Okay. So what is the property of D latch? So D latch, whatever present in the input, okay, whenever the enable signal is activated, the same thing will be transmitted to outputs. So here, let us make a table, and from the table we can see. So from the table, so this is your S, right? So this is your S values. So S value, it can take two possible values. It can take value 0, it can take the value 1. And let me call this is Y. So this is your Y. So if I select it as 0, if I make S equal to 0, okay, so so what is going to happen? The input available on I0 will be transmitted to output. So you see this 0 is connected to this Q itself. So Y is equals to Q. Y is equals to Q. In fact, Y and Q are same here. I'm just renaming it for my convenience. So when S equal to 0, then you get Y is equals to I0. I0 is nothing but equals to, this is Q. And what about S equals to 1? If S equals to 1, if you give, then input available on I1 will be transmitted to output. So what is the input available here? I don't know what is that input. So let us name this as D. So this is your D. So what you are observing here, whenever the select line is 0, so output will be same as the previous state because whatever is present at the output, the same thing will be available. There is no change because if I make S equal to 0, so this line is constantly tied to this. So whatever present here, so if it would have been 0 earlier, this will be holding 0 permanently. And if it would have been 1 earlier, it will be holding 1 permanently as long as S equal to 0. So if S equal to 0, then there is no change in the state of the output. So if it was earlier 0, it will be 0 forever. If it is 1, it will be 1 forever as long as S equal to 0. But if I make S equals to 1, then whatever you give here, the same thing will be transmitted to output. So if you are making S equals to 1, you give here 0, you will get out at the output as 0. So you make S equals to 1 and you give the input D equals to 1, you get the output as 1. So what you are observing, so if you are making the select line as 1, so if 0 you are giving, you are getting 0 output. If 1 you are giving, you are getting 1 as output. So S equal to 0, it is holding the previous state. S equals to 1, it is transmitting this particular D inputs. So this is nothing but the functionality of a D latch. So you can imagine this select line is equivalent to your enable pin of the latch. So whenever enable equal to 0, then Y is equals to Q, the previous state. Whenever enable equals to 1, output is equal to the transmitted inputs. That's what happened, right? If you remember D latch. So this is your enable signal, okay? So this is what your D is, and this is what your Q is. So what you do in this case, so in a D latch case, we say that whenever enable equal to 0, then your next state output Q plus equals to Q. Whenever enable equals to 1, we say that Q plus is equivalent to the applied input D. So you see this table and this table are equivalent. So answer has to be D latch. In fact, this much of explanation is not needed, students. So just for I'm explaining you, I'm just elaborating this much. Otherwise, just by look itself, without any second thought, somebody can tick the answer as option B. So answer is of course D latch, option B. This question is asked in Gate 23 of Computer Science. This is from digital subjects and from number system topic. The question is a particular number is written as 132 in radix 4 representation. The same number in radix 5 representation is dash. So basically, what we are supposed to do in this case is we have a number 132 in base 4. So we are supposed to find what is its equivalent base 5 number. So in such kind of cases, student, you know very well, we use the base 10 number system as the intermediate number system. So what we'll be doing is, first we'll be finding what is the base 10 equivalent of 132, and once we know what is the base 10 equivalent, then that base 10 number will convert into its equivalent base 5 number. Okay. So first let us try to find what is this number is. Okay. So how do you convert a number of any base into base 10? So just we have to expand the polynomial. So it is 1 into 4 square plus 3 into 4 raised to power 1 plus 2 into 4 raised to power 0. So this is 16, 3 into 4 is 12, and this is 2. So this happens to be 30. So that is, this is 30. So 132 in base 4 is equivalent to 30 in base 10. So if you have the number 30 in base 10, if you want to convert back into base 5, so you have to repeatedly divide that number by 5. I mean the long division process. So 5, 6 the 30, the remainder is 0. Then 5 means this is 1 and remainder is 1. So now if you see this 30 in base 10 is equivalent to 110 in base 5. Or if you convert this 110 of base 5 into base 10, you will be getting this is 30. You can check it. 1 into 5 square is 25. 1 into 5 power 1 is 5. 25 plus 5 30, and this is 0. So 30 plus 0 is 30. So this is what the answer would be, 110. So here this answer is 110. Okay. So if this 132 in base 4 is equivalent to 110 in base 5. The answer is 110. Very simple and straightforward problem, students. Answer is 110. This question is asked in GATE 23 of Computer Science. This is from Digital Subjects and from Sequencer Circuit topic. The question is, consider a sequential digital circuit consisting of T flip-flops and D flip-flops as shown in the figure. Clock in is the clock input to the circuit. At the beginning of Q1, Q2 and Q3 have value 0, 1, 1 respectively. Which one of the values Q1, Q2, Q3 can never be obtained with these digital circuits? So you have Q1, you have Q2, you have Q3. So if the initial state of this is Q1 is 0, this is 1 and this is 1, okay, then which one of the following can never be obtained with these digital circuits? So this is a student question based on the counters, right? It's a counter circuit, we can say. So let us find this corresponding counting sequence. From there we can easily get what the question is meant for. So as usual methods, so we'll be making here table. So the first table, the first column in the table is present state. There are 3 flip-flops. So let me write there Q1, Q2 and Q3. Then you'll have the flip-flop inputs. So what are the flip-flop inputs? So let me name this as T1, this is D1 and this is T2, okay, or T1, D2 and T3, okay. So this is your T1, then you have D2 and then it is T3. So now what is connected to T1? So T1, if you see, it is connected to Q3 complement because Q3 it passed to a NOT gate. So the output of the NOT gate is Q3 bar. So Q3 bar is connected to T1. So T1 is equals to Q3 bar. What is D2? D2 is equivalent to Q1. This is your Q1. And T3, this is T3. This is equivalent to Q2. So this is your Q2. So based on the present state and flip-flop inputs, we'll be finding the next state. Next state, so Q1 plus, Q2 plus and Q3 plus. So now we can write their combinations and from there we can easily get the corresponding counting state. So let me write all the combinations so that we can have a very clear picture. 0, 1, 0, then you have 0, 1, 1, then you have 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1 and 1. All right. Now, so T1 is Q3 complement. So complement of this one. So I think I have missed one thing, right? So yeah. So T1 is basically Q3 complement. So complement of this column. So 1 0 1 0 1 0 1 0. Now what is your D2? D2 is Q1. So this column I'll be copying as it is. So you get here 0 0 0 0 1 1 1 1. What is T3? T3 is Q2. So this column I'll be copying as it is. So 0 0 1 1 0 0 1 1, right? Fine. Then what is the Q1 plus? So Q1 plus Q1 is with respect to T flip flop. So it will be T1 XOR with Q1, right? Then your Q2 plus. Q2 plus is with respect to D flip flop. So in a D flip flop, the state equation is Q2 plus equals to D itself. So D2. And if I ask you what is Q3 plus? Q3 plus means T3 XOR with Q3, right? So now, if I ask you what is Q1 plus, so it is XOR combination of Q1 and T1. So these two columns should be XORed and it should be written here. Because that's what the state equation says. So 0 XOR 1 is 1, 0 XOR 0 is 0, 0 XOR 1 is 1, 0 XOR 0 is 0, 1 XOR 1 is 0, 1 XOR 0 is 1, 1 XOR 1 is 0, 1 XOR 0 is 1. Is that fine? 0 1 1, 0 0 0, 0 1 1, 0 0 0, 1 1 0, 1 0 1, 1 1 0, 1 0 1. That's fine. So Q2 plus equals to D2. So this column I'll be copying as it is. So you get 0 0 0 0, 1 1 1 and 1. Okay. Then finally Q3 plus. So I'll be making the combination of XOR combination of this and this. So 0 XOR 0 is 0. Then 1 XOR 0 is 1. 0 XOR 1 is 1. 1 XOR 1 is 0. Right. So I'm doing XOR of this column and this column. 0 0 0, 1 0 1, 0 1 1, 1 1 0, 0 0 0. So this is 0. Then 1 0 1, 0 1 1 and 1 1 0. Is that fine? 1 1 0. Then 0 1 1, 1 0 1, 0 0 0, 1 1 0, 0 1 1, 1 0 1, 0 0 0. Fine. So that is what. Now the point is we need to understand one point, that the initial state which is given is Q1, Q2, Q3, and the initial state is 0 1 1, you see 0 1 1. So we'll be taking the reference as this row. From here we'll be finding the counting pattern. So now if you see, students, so if I ask you what the counting pattern of this counter, so the initial state is 0 1 1. So from 0 1 1, where my counter is going? My counter is going, if the present state is 0 1 1, my next state is 0 0 0. So from 0 1 1, it is going to 0 0 0. So now if the present state is 0 0 0, the next state is 1 0 0. Next state is 1 0 0. If the present state is 1 0 0, the next state is 0 1 0. Next state is 0 1 0. If the present state is 0 1 0 now, next state is 1 0 1. Next state is 1 0 1. If the present state is 1 0 1, next state is 1 1 1. If the present state is 1 1 1, next state is 1 1 0. If the present state is 1 1 0, next state is 0 1 1. So it is 0 1 1. Right? So let us understand again. From 0 1 1, it is 0 0 0. So 0 1 1 to 0 0 0. So now you have 0 0 0. So from 0 0 0 to 1 0 0. So you have 0 0 0 to 1 0 0. So now you have 1 0 0 to 0 1 0. So 1 0 0 to 0 1 0. Then from 0 1 0 to 1 0 1. So 0 1 0 to 1 0 1. So from 1 0 1 to 1 1 1. So 1 0 1 to 1 1 1. Now from 1 1 1 to 1 1 0. So 1 1 1 to 1 1 0. And from 1 1 0 to 0 1 1 again back. So this is what the counting pattern is. So in this, how many states are present? 1, 2, 3, 4, 5, 6, 7 states are present. So what is the thing which is missing? I think 001 is missing, is it? Yeah, except 001, everything is present. So 001 is not present in this counting cycle, and that's what the question is framed. Which one of the given values of Q1, Q2, Q3 can never be obtained? The answer should be 001. It is option A, right? So if you do this counting table and if you obtain the counting pattern, very easily you can visualize the picture. So answer has to be 001 in this case, option A. This question is asked in Gate 23 of Computer Science. This is from digital subjects from combination circuit topic related to multiplexer concept. So students, overall what is given is this circuit diagram is given and the output expression Q, what is desired is given. So we expect the output expression Q is equals to this expression. So what should be connected to this x0, x1, x2, x3, x4, x5, x6, x7 such that this Q is equal to this expression. That is what is the question given and this is the circuit diagram. So we have this expression of Q. What should be the input to this x0 to x7? That is what the question is. So, okay. So now student, if you see, so here the select lines are AC to these two multiplexer M1, M2. Select line to M3 is B. So if I ask you to write the expression of this Q, so let us name this is Q1 and let us name this is Q2. So your Q in this case is your B bar Q1 plus it is BQ1, right? When this takes value 0, if this takes value 0, that means it is B bar Q1, and when this takes value 1, then it is B and this is Q2. It is Q2, right? So B bar Q1 plus BQ2. So this is what is the expression, okay? And my desired expression Q is equals to your A bar plus A bar C bar plus A B bar C, right? So you expect this and your circuit is giving this. Now what should be connected to Q1 and Q2 such that this is what is desired? What are Q1, Q2? The output of this and this. So if you get what should be the output of this, I mean multiplexer Q1, Q2, we can easily figure it out what should be the inputs. Okay, let us see. So here, the point is, friends. So in the format where how we are getting the expression here, we have everywhere B is present, right? But in the this expression, B is not present here and here. So B is present only here. So let me write it in its equivalent form so that every term will have the B term. I mean B or B bar, so that we can separate the term with respect to B and B bar. Then the expression will be in this format. So for that, you have to write the expression in the canonical form. So there are multiple methods how to get the canonical form. So I'd like to go by the mean term methods. So in the first term, I have A bar present, BC missing. So I'm writing the combinations of BC and A bar is 0 constantly. So next, you have your A bar, B is missing and you have C bar. So this is 0, 1. A bar means 0, 0, C bar means 0, 0. Then you have A, B bar, C. Here all variables are present. It is 1, 0, 1. So from this you get 0, 1, 2, 3. 0, 1, 2, 3. From this you get 0, 2. From this you get 5. So if I ask you for this function, what are the mean term combinations? So the mean term combinations are 0, 1, 2, 3 and 5. So this is what the mean term combination. Now if I ask you to write this mean term in terms of canonical form, 0 means what should be the representation? It is 0, 0, 0, A bar, B bar, C bar. Then you have 1. 1 means 0, 0, 1. So A bar, B bar, C, 0, 0, 1. Then 2 means 0, 1, 0. So A bar, B, C bar. Then 3 means 0, 1, 1. So A bar, B, C. 5 means 1, 0, 1. A, B bar, C. Right? So this expression is equivalent to this expression. So now the difference is here I have introduced the B variable everywhere so that I can make comparison and I can easily reach once I get Q1, Q2. I can easily, if I know the Q1 expression, what should be the input here, I can easily figure it out. So now let us arrange this in the desired form. So if I take B bar common, so B bar I can take common from this one, and this one from these three terms. So it is your A bar C bar plus your A bar C and plus your AC. Similarly, from these two terms, I can take B as common. I'll take B as common. If I take, it is A bar C bar plus your A bar C. So now you make comparison of this one with this expression, right? You make comparison of this and this expression. So what is the conclusion? So you can see that conclusion Q1 is equals to your A bar C bar plus A bar C plus AC. Yes or no? If you compare this one, so Q1 is equal to this one. A bar C bar plus A bar C plus AC. Similarly, what is your Q2? So Q2 means what? What is multiplied with B? That is Q2. So this is what your Q2 is. So A bar C bar plus AC. So you got Q1 and Q2. You got Q1 and Q2. Now you can easily figure out what should be the input here. So now students, so suppose for example, if I ask you, okay, what is the Q1 expression here? Now you can easily figure it out what is the answer. Q1 is equals to, you can see here. So 0, 0, A bar C bar. So you get it is A bar C bar X naught plus A bar C X1 plus 1, 0, AC bar X2 plus AC X3. So we expect Q1 to be A bar C bar plus A bar C, and you don't get anything with respect to AC bar, then you get AC. So that means X0 is 1, X1 is 1, X2 is 0. So that AC bar equivalent to 0 and this is also 1. Now you see here, so X0 is 1, X1 is 1, X2 is 0, X3 is 1. Similarly, if I ask you to write with respect to Q2, so Q2 is equals to, it is your A bar C bar X4 plus your A bar C X5 plus your A C bar X6 plus AC X7. Right? And what do you expect? You expect A bar C bar plus A bar C. So it is A bar C bar. This should be 1. I want to retain this term. Next term is A bar C. So you also want this A bar C. So this should also be 1. Now remaining these things should be 0. So that this term won't appear. So this is 0. So X4 is 1, X5 is 1, X6 is 0, X7 is 0. So X0 to X7 pattern, if you are expecting 1, 1, 0, 1. So it should be 1, 1, 0, 1. Right? 1, 1, 0, 1. Then 1, 1, 0, 0. Then it is 1, 1, 0, 0. So which option is satisfying this one? It should be your answer. 1, 1, 0, 1, 1, 1, 0, 1. If you see, that is being satisfied by option C. Yeah, 1, 1, 0, 1, 1, 1, 0, 0. It's satisfied option C. Yeah, it's a good bit tricky problem. Tricky in the sense, only thing that should strike your mind is how to deal with this expression, right? There are other way also you can verify the options by eliminating option also you can go through that. But this approach what I did, I think is pretty convenient and easy and straightforward. I have taken around 5-7 minutes of time because I'm explaining you. But if you solve in proper flow, these all steps are not required. So once you are reaching into this expression, so directly from this expression, you can pick it up what is the right answer. So if you solve as expert students, it is not even 3 to 4 minutes off. So answer is option C for this.